Hey everyone, in this video I'm going to show you how to integrate one element of electromagnetic radiance through a rectangular aperture with height by, width bx. It's going to be a double integral, integrating once over the width and the height. Inside the integral we have an x and an x prime, as you can see, as well as a y and a y prime. The x's correspond to the actual aperture, or the x and y's are the actual aperture. The x prime and y prime are the screen where the diffracted ray appears. If you want to find out how to reach this form, or in the geometry behind it, there's a lot of resources online. However, when I had to do this, I didn't find any resources in terms of the actual integral and how to reach the Fraunhofer expression from the integral itself, so that's why I'm doing this video in hopes of helping somebody. So if you want the expression for just one element, you put a d here, so dE, you get rid of the integrals and the dx and y's, and you get the expression for just one. But if you want the total, we're going to have to, integrate over the entire aperture. So that's where we get a double integral from. I'm not going to work with this. I'm only going to use the integral. And so I'm not going to keep rewriting this part. I'm just going to work with this. So I'm going to put an arrow instead of an equal sign. So we can go ahead and rewrite this integral. So assuming our width is bx, we can integrate from negative bx over 2 to bx over 2. So it covers the whole width. Same thing with the height. Negative by over 2 to by over 2. We rewrite this e minus ik xx prime over r plus y prime over r, like so. Dx dy. It's a little scrunched up here, but it's fine. Okay, so from here, you can split the integrals. Negative bx over 2 to bx over 2. From calculus, so we just take only the x components and the y components, we split it into a product of two integrals. E negative ik xx prime over r dx multiplied by from negative by over 2 to by over 2 e I minus ik y prime over r, like so. dy, don't forget that, so you lose marks on the text. Now, at this point, this kind of looks ugly, right? So we're going to use this substitution, these substitutions, as you can see. So they equal everything here except for the y, okay? So our integral is going to look a lot nicer here, except for the y and the x, right? It's two different factors. So this becomes e big X, little x, dx, from negative by over 2 to by over 2, e, large y, little y, dy. Now this looks a lot easier to integrate than that. So once you integrate it, here's what you get. E big Y, little y over large y. Here are the limits, multiplied by e, big X, little x over big X, from this is positive bx over 2 minus bx over 2 at the bottom. So now remember, when you evaluate the integral, you plug it into the y and the x, right? Like the small ones. So here's y equals, this is x equals. Okay? Once you evaluate this, I'm going to skip a step. So you evaluate this and you plug it in already, okay? So I'm going to go ahead and do that. Here's what we're going to get. R exponential minus I k. We'll start with the x's. No, we'll start with the y's. This is for sake of order. Y prime by over 2r minus r exponential. This is positive, sorry. This is negative. K y prime by over 2r all over. We have, what do we have here? When we plug in the y, right? So the r went up, so we took the r at the bottom. We're going to have a negative I k y prime, like so. okay? This is multiplied by the x part, r, e. It's a little repetitive, right? All we're doing is like switching the x's and the y's, but it's worth just paying attention to this. X prime bx over 2r, all over minus I k x prime. Okay, so it's the expression that we get after evaluating the two integrals is the multiplication of two integrals. Now, we proceed to use our other substitution that we had written previously here. Right? So I'm just going to keep writing up here. Okay? So now, here's what we're going to do. We're going to take out the r's. So we need, essentially, to reach this form. Okay? We have, here's our exponential. So we have an I. Here's the I, and our x is going to be this whole expression, which, luckily enough, is just going to be one of these. So we can rewrite this. So we take out an r outside. We take out the bottom. Let me just do it over here. R over. Okay, so you understand. I'm just going to work over here. Now, so we take out the r. So essentially here we need a negative 2i at the bottom. We don't have the 2 here, we just make one. So we take out a 2r instead. And then we want to leave the I and the negative sign. So all we take out is the k and the y prime at the bottom. Ky prime. And we're left with e to the I. So what's this expression without the I? That's just going to be beta y, right? Ky prime by over 2r, yeah. Beta y minus e minus I beta y, like so, over minus 2i. So I'm going to continue over here. So it's still only one expression, I'm just multiplying it. So the same thing with the x's. We take out a 2r, we take out a kx prime, right? So we're just leaving the I and the negative. We're going to be left with e to the bx I minus e minus I beta, x over minus 2i. Now, lo and behold, we have reached this expression with our x being beta y, or beta x in this case. So then from here we can rewrite this expression as 2r over kx prime sine beta x. Beta y, beta x, beta y, beta, okay. So this is y. Sorry about that. Y prime, beta y, okay? And 2r over k x prime sine beta x. So, starting to look good, but we can make it look even better. Here's how we do it. We use these again, okay? So what we want to get rid of is these outside, so the factors outside of the sign. How do we do that? Well, it kind of looks almost, so this is basically like the reciprocal of this, the inverse of that, except for what? Bx and by outside. So this expression essentially equals sine beta y over beta y, except only thing we have outside is the by, right? Yep. And for the x, it's the same thing. Sine of beta x over beta x, like so. So we've evaluated the integral and we made it look nice. Now we just add the factor outside, okay? So again, this does not equal that, okay? Because we don't have this factor outside. However, now this whole thing, so E is going to equal E naught over A, E minus I omega T, E I K R, I know, right, over R, times By sine beta y over beta y, Bx sine beta x over beta x. And this is the final expression for the Fraunhofer diffraction expression.